Okay, hello guys, my name is Goldman. So I'll be creating a bank. All right, I'm going to start from the very scratch and assume this is a learning process and we'll learn together. So first off, I want to really know what is a bank. All right, yeah, let's see. So is the bank's licensed financial institution that accepts deposit, blah blah blah, from public and uses those funds to make loans. Yeah, okay, this is a function here, make loans, by acting as a secure place to store, okay, store, okay, and a source of credit, bank facility economics to allow individuals and businesses to manage and grow their finance. Source of credit, and it's facilitate economic stability. That's not a problem right now. We've gotten three functions: source of credit. Guess the reason why it provides loans, allow individual business to manage and grow their finances. Okay, and that's where the last part. Okay, core functions bank, very important. Accept deposits, money in various types of accounts such as lending. They pull the money deposit by customers and lend it to individuals and business functions. Interest bank pays deposits a small interest rates on their saved. Okay, charges for borrowing. That's what this means. Facilitates payment. Okay, here's a function. Main type of banks is not a problem right now. I want to be the bank. Make it generic for a start. Then as we go on, can decide to make it a series and can see how to create a diverse kind of bank. Okay, so as usual, I would like to create a diagram to best communicate the sense. So we all be in one piece, right? Okay. As usual, I use my guy draw.io. So I want to create a bank. Okay. Alright, cool. So right, so I want a blank take this scat, just make it blank. Okay, so on a search icon of a bank. So let's see what we get here. Ouch, no good image. Let me take this. Okay, so I don't care about the definition right now. All I care is the function. So there are a lot of scattered function here. I follow this, then I'll look through the definition to map out the function because I'm very much concerned about the function. The function most times communicate the sense of what a thing is, and the thing here is the bank. So it's accept deposit. That's one function, right? So can money, right? It's not good. Coin. So this bank paying money. Putting money here. Bank. Let me change this arrow. Sorry. Yeah. So it's a deposit action. So excuse me. 16. So deposits funds, right? So deposits. The other function makes it a bank. Then lending. So okay. They pull the money deposited by customers. So this bank is gonna create a pool. Pull these funds, right? Let's see how it pool looks like. Let's go with this. It's okay with this. And it's perfect. Alright. Drag this thing. Okay, sorry about that. And look for the perfect guy. Nah, it's never cool. Like that. I think this represents a bit too far. Just need a cone to show. It's a cylinder, sorry, to show. Okay. Just call this the pool. So bank creates a pool. And here. Okay. Create a pool. This pool contains create a pool of funds. Okay. Change. Pool of funds. Yeah. The pool of funds. Then next lend it to individuals. So this pool of funds will be accessed by individuals, can be lent to individuals. Call these people. Okay. Yeah, I think I want to use the star because the star kind of signifies kind of special people, right? So nobody comes to this pool to take money if you're not eligible, right? So yeah, the pool service these guys, and it's better for me. Who services guys, and not random people. So yeah. Communicating the sense and like homes, cars and business. What? Homes. Wow. So people to bank gives our money to homes. Interesting. Forward to run family. Okay. Interest. Bank pays deposit. Okay, I get it now. So this pool is what each person that have deposit in here comes to take. So in the real sense, you deposit your money, it's been put in a pool. This so create call call this a withdrawal pool or a general pool, or I don't know. What kind of pool is that? Yes. So way. Loanable pool. Interesting. I was thinking this was already making a different sense from like a pool, like a withdrawal pool. Okay, interesting. So I guess I just make this create withdrawal pool because the description was kind of off. Right, there has to be two kind of pool, right? So we don't need to have one certain kind of pool from what I can understand here, because interest bank pay depositors a small interest rate on their saved money while charging for us a high rate on loans. Okay, I want to complicate the whole thing here. I'm going to leave my diagram this way, right? And I'm not calling this a withdrawal pool anymore. So I'll just stick to the functions, the general pool, and interest, bank paid interest system. I need a complete engine. Yeah, an engine or a computer, right? That serves as the interest guy, right? Compute the interest. Oh, I wanna call this interest. Interest. Let's see what happens. Rate of interest. Yeah, oh, interest. Just choose government. Okay. Calculator will be very good at representing an interest, right? So let's do it this way. Let's make it a bit low. Okay, cool. Now, yeah, now I want to change this way. And, yes, go this way. Call it low. These are the functions, right? So calculate interest 6. Ooh. So calculate interest interest. Yeah. Okay, cool. Calculate interest. So I want to do is bank calculate interest for you, and the interest is tied down to money you borrowed from the pool. So this bank has a way of reading the data from whatever happens in the pool here. Then for stating payment, Okay, payout. Now nobody comes to the pool and just take out money, right? This is where the payout comes in. It makes sense. So have a payout guy. Payout. Just see how it works like this. A cashier would be nice. Cashier. This payout. So this payout. Okay, cool. Switch this. No. Okay, call this payout. And, pay these guys. Just pay them. Sorry. So what the payout we want to do is, yeah, so nobody have direct access, security reasons, so I'm already, so take this out, and I think the bank has only direct access to pool, then bank calls payout. This is the point where there's a connection to people with the phone. So I readjust this, take it a bit down, sorry. So yeah, take it a bit down, yeah. So call this 6 payout. So payout. First payout. Now let me see if I've satisfied from the definition the functions that exist there. First is deposit. Yes, deposit. Uses those funds to make loans. Okay. This will be solved with the payout from here. So there have to be like a calculation of interest before the payout stuff, right? And credit if done that stick. So pretty much these are all the functions. Now we're going to build this, right? We're definitely going to build this. We're writing a smart contract that works as a bank. We're creating a bank, a decentralized bank. It already exists, but then let's see how it goes up, right? So these are the functions. We're going to be building this on Sui. Create a pool. So there's going to be a pool. There's going to be a bank. Going to be payout. And there's going to be guy that calculates. So these are functions, right? So yeah, let's start up. So first thing I want to do is open up my terminal and move into the project DR and new bank. Simple, just a bank. Then seed into the bank, move into the bank, and start building this bank. Like it's a package called bank. Interesting. So it's interestingly, I'll be using, how would I want to use it, because I want to view the APIs here. So I'll be using zip, and yeah, so this is how the bank should looks like. very simple. So what I want to do here, now is this. Very simple. So let me enlarge this a bit. So I want to view this contrast rate. Now I'm just building this for a reason, a very singular reason, so I can have all the APIs for the swim move library or all the dependencies that I'll need to come in, because I'll need to look up some things and check them out. So let's just give some time for it to come in. So yeah, so find them here. So these are all the dependencies we're working with. We'll work with all this pretty much. So first, how my bank look like? So I'll comment this and this, right? And first off, for it to be decentralized, we have to talk about the DAO, right? But then I don't want to go through the route of creating a DAO first. What I want to do first is create a modular system that reflects a bank. So we already have a model, because this is a model called a bank. So what I want to start doing now is to write a function. Alright, in this bank I have to write a function. So this is going to lead us to a lot of stuff. So first off, these guys need to deposit funds, and they're depositing it in the bank, but the bank has a pool where every fund has to go to, right? So yes, so that's what we have to do. Create a function that comes into this whole bank, right? So right, I want to create a public function that can be easily accessed by anyone, right? So I'm gonna call it deposit. Yeah, so I want to pass some kind of amount, deposit. So want to make sure the depositing, I don't want this AI to do anything. How do I deposit? But then it's being handy. So first off, so I want to assert that the value that is entered is greater than 0. Yeah, I want to go through that now. That'll be checked for some models, right? So first off, I want to receive some money. So what I want to do is I want to use the standard library, to use the debug to actually print out what I'm getting out, right? So you can see what we get. Just print out the amount, right? This one. So yeah, so this will show you that this function works, but then let's just go in very serious, right? Very serious matter now. So depositing money, an amount in traditional bank, if you have to fill in a teller, right? So why depositing, let's call this function, let's consider this function to simulate like a teller. Alright, so simulate a teller. Everybody has an amount that wants to deposit, very important. and it has to be deposited to. You have to, let's go up through from the teller. There has to be a timestamp, which is actually date. Let's call it the date. Here we'll present it is 4. Then the next thing we want to put in mind is the amount. We've already gotten that. Then who is receiving it? Recipient. There's an address, right? Then we've gotten date, recipient, amount, and a signatory. So the best way to pass in signatory in here is by using this. So the amount, date, recipient, signature. Okay. So so we need to pass in some amount of funds. Now we'll have to put in mind that depositing some money, obviously naira, so I have to pass in some account, some funds, some coin, right? We need to pass in type of coin they're supposed to deposit. So we need to pass in coin type, or say currency. Interesting. Currency is not going to be an address right now. I'm going to pass the coin. So coin is going to stem out from sweet coin. So if you check down here, check coin, it's going to see it, and you see the coin. You're going to see the coin struct, or the coin type. Past it, I guess. So the coin. So what I want to do is pass in coin, the type. So we want to provide everybody coming to this platform to be able to our bank to deposit any kind of token that they want. Won't give them that luxury. So that's an API. Okay, so I just had to look up how to call this type, right? Now we can deposit, and we're depositing to an address, right? And yes, that's how it works. So what they want to do here, we want to receive that funds and put it into we'll receive this fund and put it into the pool, but then we'll have to log in all this information before putting it into the pool, right? So we need to, like, this bank needs to have like a ledger. So we want to have a ledger. So first off, what we're going to do, log data to ledger. Yeah, that's what I want to do. Then put all the entries into the ledger, then move the coin to the vote. So this is how I want to design this. So I'm going to create a ledger, call it public struct first, then we have the ledger. Now this ledger, we're going to go bit by bit. This ledger is going to hold data that has to do with the user's activity in the bank, the deposit and their withdrawal. It's kind of a cash book. Okay, so there's going to be the deposit side, so there have to be two corresponding sides. Not going to be easy, but we're going to get it done. So going to be two entries for any transaction. So that being said, we're going to have debit side, going to contain some lists, transaction, debit transaction, right? And for now, I'm going to call, how do I arrange this transaction right now? I'm going to make them a table. So table, yeah, we have two sides, debit and credit side. So what we want to do is very simple. We want to log in some information into this part. So we're going to have string, then yeah, pretty much string. This we're going to have currency. Oh, we have date. We have recipient date. So we have the amount, we have the date, we have the recipient. So we have now very easy. So we're going to tie down the address to list again. So tie down the address to two lists. The first one is going to be the address, and the second one is going to be the date. So that should work very well. Does that represent the transaction properly? Okay, this takes us to a little bit deep search. Let's familiarize with data types that are currently existing in the book. Okay. Better still, instead of doing that, that's not optimal. So the transaction, this holds transaction for debit transaction or credit transaction. We're just going to create another struct called the transaction struct. Transaction struct, yeah, transaction struct. Now this transaction struct it's just a data. So currency, it's going to hold coin type, the warrant and ID. I wouldn't want to do that, so I'm pretty much concerned about the amount and the coin type. Okay, so skip that. First off, I will have the amount, skip that. Next thing I want to do here is, and this transaction needs to be unique in a sense. Excuse me. So need to have a key. So there's an ID, there's an amount. Transaction is supposed to reflect the currency. How am I supposed to do that? Currency is just supposed to be in the string. I'll get that figured out. Currency needs to be in the string. So I want to hold this one, should hold value. Okay, the value is supposed to be held in the pool. So on the date, so we have an amount, date, and perform the transaction. So it's complete because have an amount, have a description, have a currency, have a date. So have a description, have a type, very important. So it's still leads us to the notebook of dealing about types. So we have some enums here, not really clear about the enum thing. So okay, cool, it works. I think I can work with it from here. Come on. So I don't know about the types, so then sorry, I call this transaction types. Okay. Then what I want to do now is it's just with deposit or withdrawal, just having two type of transactions, and that's what I want to do here. So with this, I think we'll have a good transaction history. So we have an amount, currency type. So this transaction has the origin, address, and then destination. Source it properly, where the money is coming from, where it's going to. So these vectors needs to have this instead. So having, gonna have a list of transactions here. List of transactions. They have to be correspondent transactions. So credit here, debit here. So it's going to be, solution says that means we're going to be creating double transactions for going to be 2 entries for each transaction. So pay in money to a destination address, so there has to be a debit entry for destination, a credit entry. Yes. So the balances are not going to be even. So we'll cross the code here. Okay, cool. Why is this so? So now, yeah, I think this is satisfied to some extent. So what we want to do now, I want to write to the ledger. So simple. Now what I want to do right now, not yet, I'm going to create a transaction, right? So like this is a deposit, right? So but then this is a transaction. The ledger needs to, there needs to be a source of truth that shows me my balance, in that household funds, by the household funds. So they have to be this is already unchanged, so there's no need to do that. But then we just beat in the bank. So that's the game we're trying to solve. Just beat in the bank. So just beat in the source of truth. To separate this, trying to separate how it will look like a debit and how it will look like a credit on this place. Okay, so let's go. The ledger, right? Before creating, have to create a transaction. Increase somebody phone, so I have to create a transaction first. So I've created new transactions. Yeah. So now this has to now the this is decentralized. Don't need to do this. It's already a chain. But I wanted to like show you guys how it will actually appear if we have to implement the same thing chain. So it makes sense, make no sense engineering this because implement was already existing. So there's already a ledger, right? Chain. So what we should focus on doing now is taking these funds and locking it up in this vault or this pool. So deposit and put it in here and have a record, right, which is a transaction record that shows that this is for this person. Okay, so we'll have the record in a particular place, right, that we can easily look up. So when we want to take out fund from the pool, you can seamlessly say, okay, fine, you are entitled to a particular amount of funds from the pool. There needs to be a record that bears that, right? So the bank keeps that record, right? So I'll go very basic first. Let's create the pool. Bank has a pool, and that pool has balance is going to be a balance check properly. Balance of type T, and that's it's gonna be here. So now this pool needs to have record to know who and will have an amount here, who has money here. So there has to be a record that has list of everybody and their balance in this pool. So it's going to be vector of record. It's going to be vector record. So you have public struct now this record is going to have this and that, and account is going to be an address, and the balance is a share of ownership. Then not to the engineer, we do it like this. So we won't go through, we can see you and see your balance. So we have a transaction which we won't need because the chain already holds this. So chain already hold this. It's not a business anymore to repeat and beautiful engineering job. Probably have later. Just creating a bank and want to see how it's going to look like here. Now it's simple. We have record and we have the pool that have this record that ties each user that have a balance to the actual balance in the pool. So there's an amount. There's currency, the same thing here. So we're gonna split out based on this, get it and move it to right to. So what I want to start doing first, me, is going straight to the business, just moving out resources or assets. So I want to get coin first, get assets. So I will be able to perform that using the coin split coin function. I'll be looking at API now. So we're doing coin, pass an amount you want to split out, get the coin out back. And so I'm going to call free the coin model split coin of type T, pass in here. I'm going to take in so I can actually implement this without running this. So I can coin or asset right assets, yeah, for the money, right? Money, but one thing you want to split it out, so you can call the split this way. Split, excuse me, call the split out this way. Neglect this, passing the amount on CTX. Has so since this is the same with this guy here, you can call the function just like the way you have in programming, when you have a class or a Rust where you have traits. So this has a trait of split coin, so that's how I could call this split coin here, passing the amount and CTX specified here. So I've gotten the coin out, so I can have the coin, I can put it in the can put it in the pool. Right, then yes, you can put it in the pool, but before I put it in the pool has to be passed in here. Yeah. Pool has to be passed in here, so the data I need to prepare, which is a record, so I need to create a record for this transaction. But before I create this record must have existed. This record is just like your account that is being held in the bank. So the best way is to call this account, so we can relate with this traditional. So I have an account right now, so this account is presumed to be created before now. So this is what we do. Just like in Rust, we have to pass it as mutable reference, not an ownership, but you can change the state. That's what it means. So it is assumed that this has been created before now. So before, you must have performed a deposit into this bank of ours. You need an account. So that implies that you need to call this function, create an account function. This AI is too much. So you create an account. Now the beautiful thing here is you can create different kind of accounts: USDT, USDC account, C account, a word, account, whatever. Specify the type in here, create the account. To create account, what is needed to create an account is just an address, and that's all, nothing more. So you need to pass your address. So you don't need to even pass your address in this case, because you can take advantage of the context of the chain to create. So we're supposed to return this way. See why the AI is not good. You have to complete a lot of nonsense for you. So yeah, so what I want to do here now is return this. Okay. When an account is created, it's supposed to be moved into a pool, right? So much reason why I wouldn't want to put the books, right? The account, that's the account which I call the book right now. Much reason why I wouldn't want to, put it with the pool. So there could be decoupling and composability. Yes, so you can seamlessly read the information in someone's account without having to mess around the pool. It's beautiful around separation of concern. So for me, I think this guy here is not necessary. The less we meddle with him, the less risk, because we have balances here. People can, so we know how to mitigate things. So the account can live on chain. Well, you can query the account and see the balance and leave the pool alone. So the responsibility of you and the pool is to go and view. And this gives us an upper hand, because we can decide to take things further and say we want to use growth system to prove your balance, because we've encrypted the balance. It's possible. So when we encrypt the balance, we definitely have some long gibberish that we can save in U256. So what we want here is, excuse me, don't do that. I want an ID, and you have objects. Can you imagine? It was giving me nonsense earlier. So you have CTX. Yeah, CTX. And sorry, the next thing is we want to call this account number. I don't want to call it anything more than that. Excuse me. Take the sender. Then main, you have a 0 for a start. Okay, so this now is a detail. We can decide to go some bit further and make it an NFT and send it to your address if we want. Can do that, but it's not needed. We're concerned about truth numbers. So account has been created right now. Account. So the next thing we want to do right now is to the pool. So pool is just there, and yeah. So before you deposit, you must already have this. So this is enough. So for you to use this function, you must just have an account. Then deposit, we don't care. So you must not actually have an account to make deposit in a traditional bank sense. You can run this errand for someone else. So provide an account detail, provide a pool, and you're good to go. In traditional banks, you just provide the account detail and you hide the pool. I wish there's a function to actually get an object based on type. I wish. Let me see if this guy is downloading. I guess we're going to crack our head today. So, okay. So, how do I get object? So, looking for ways to avoid this. So, let me see. I think if I use this self, self serves completely different purpose depending on the context. When importing, lets you reference the host model directly. Business is blah blah blah. This limit needs to write lines for model itself. Examples self. So you have coin, right? That's one. Second is receiver self. First function. First parameter, this enables method. Yes, it does. And you can just call the function using dot. Yes, I did that. Idea. save that function. So now I can play. Okay, I have to pass in this guy. Let's just work with that for now. So very simple. The first thing we want to do is to add value to the account, then put the money for the split. So we call the account dot balance equals to amount plus account dot balance. So I've updated the balance and the next things. Yeah, that's pretty much what needs to be done. The destination recipient. So this is a check. Pass the account and the recipient. So you have to make sure the money that is being paid is paid to the right account. The way to do that is by doing this simple accounts, that's account number, make sure it's equal to the recipient. This is how we start it. If it's not create constant much. Okay. Okay, so this is what we want to do. Yeah, match. So once it matches, update the value and the date is not useful. You can only see that on change. Sorry. Thank you. The amount has been used, the money has been used as well. Recipient pool, I think every other thing. Then metadata has been done. I mean, if everything fails, it fails automatically. So metadata has been done. We pool dot balance. Now let's see how it handles balances and how to balance. The function for it, join. I just have to join the balance at the column. Okay, join it, but I have to so I have to convert this asset to balance. here. Balance. I don't need to worry, but I just need to look for a function that returns balance here. That is okay. This means look for return big balance. The actual balance, not a reference. Into balance, yeah. So this function, take it as advantage of building first because you can look through the APIs. The advantage. So do this, pop. So asset balance. This is not needed. So now what have I done? Simple. Simple. I have asserted that I'm making the right transfer to the right destination address or account. Then I bump the account balance by the amount and get the assets from the coin that has been passed and split it out to get the amount, the amount to get the assets, get deposit amounts, get deposit amount, leave it there. Then the deposit amounts has the same trait as this, so I can seamlessly call this function to convert it to a balance, and I convert it by pass it in here, and it is being joined to the pool. Now I'm supposed to create a pool with a zero balance, so this is supposed to happen immediately I publish my contract, right? It's not supposed to be done by anybody. So I'm going to call a function an init function. Sorry, init function. CTX. It doesn't return anything. Then create the pool. So create pool. So primarily how to create a pool is simple. Let's pool. So the pool is unique. So the pool is unique, meaning it's unique due to it's unique because for different currencies, so this won't work. So I just have to make this a public function that could be called by someone with yes, by the account with the upgrade cap. Yeah, I could use my contract upgrade cap for it, but is that decent enough? Somebody upgrading his contract should be very important to you, so nobody comes to upgrade it, else money will lose it. That's not. There might be a lot of engineers working on it, so they might have an upgrade cap. But for now, it's just me, so I'll leave the logic this way, or I wouldn't risk that at all. I'll create an admin. So you can create. So it should be an admin. So create pool. Passing type pool. I have to create CTX. This pool is returning nothing, so I'll just call the pool struct this way. So ID, then what does my pool need? The balance. Now this is where the bingo goes. If I can create a balance 0, so we'll look that up in the API. Okay. Wonder what that will be. I think I just need to look for a balance. Yep, found it. So I can just call this tree balance yeah, just this way. Tree balance doesn't require any CTX, just works. Okay, so I'll take this off, save it down. So create pool CTX tiny CTXT. Yes, I need CTXT here. So objects. So this is what I have here now. Cool. So create a pool. CTX ID balance round up to 0. Yeah, perfect. Check that again. Perfect. So we can call it. So for any pool. Now here's one thing. Pool is a type. Balance 2 has a type. Yeah. Now with this, anybody can create a pool. It's crazy. Don't need to do that. So this takes always last argument. So with this, so I would need to create passing that a capability that shows this is an admin. Imagine a manager in the bank. I don't think you should be able to create a pool. I mean, you wouldn't receive a currency that is not supported by a bank. So who has to do that? A CFO, Chief Financial Officer. Yeah. CF hookup, and this will be created upon, when it's created it will be sent to the owner. So function it, CTX 90 that, let me see. This is a read, sorry. See all that. Then we're done here. So after creating this, we wouldn't leave it here, right? I want to transfer this. Intelligent. So okay. Gonna be shared object because we pull. It's gonna be probably shared object. Which is this. So probably shared object. Pull. Just simple. Just this way. Check. Is it requiring anything? Just the object. Okay. So I want to create CF hookup. So I need to write the struct. Let's start it here. And the key. Okay. So this is it, and this will be transferred. Public transfer, and that's because what I've done just transfer. That's because it has a store. Sender. So it works. So the person that created the account, the package can decide to, benevolent transfer the cap to create pool. So for now, this is how it should be. Then missing anything. The pool has been created, the account has been created, deposit funds this way, and there has to be a meet event. Kind of something else to write that. Let me see if this project is complete. File build. Okay, let me build first. See what I have. So he could not resolve balance, and 13 unbound type amount 13. Okay, that's true. It's accounts balance is supposed to be 64. Yes, first no salt. Then 17 balance is supposed to be 3. Then 20. To certify the content stability. Yeah, store should be added there. Since I don't have any intention of storing it anyway, so store will not be added. That implies this has to be transfer. Yep. Then create pool some public says unbound feed ID. Ouch, that was good. That was very good. Yeah. So this is how it works. So then key bank does not go with key. We'll fix that and transfer shared object. Stop. Okay. Since it doesn't have store, move the public. Right. On what line is that? 39. Almost 40. So it's not being stored under any struct. So the public. Then it's saying giving what function is this? 5. So says expected bank given this. Actually yeah, that's because this is supposed to be here this way. Yeah, then because of the system, this is the loop, right? And it returns nothing here. I need to check or something. Trying to wrap my head around this. Okay, let me go down to 43. Six unbound variable ID. That's for account, right? Yeah, I have ID. Also delete here ID. Then wow, expected a single value mutable, money expected 67. Okay. To use the mute variable, it's use mute. So money is being mutated, right? Oh, interesting. How did I work that out? Then it does not have the ability to drop. That's what it's saying. It's invalid return. What doesn't have the ability to drop? Yeah, that's true. Okay, so try out something. This one. This is something. Okay. Okay, this is what we're gonna do now. This is supposed to split. This function is supposed to be able to be called just this way. But then it shows this. Oh god. Okay. To use the variable mutable, it must be declared mute, example mute. Okay. Okay. Let's go again. So, guess that is resolved. And use type T. It ought to be used somewhere. Yeah, it's supposed to be used here. Splitting some tokens. Getting balance of some tokens. Yeah. Joining some tokens. Yeah, so let's see what happens. It's still telling me I use T. use T 43. Yes. Then this is not needed since yeah, that's true. So telling me 67. Why? Okay, it's saying okay, this guy that spits out the amount going to balance and so invalid return. Satisfy the condition, the draw probability needs to be added. I can't do that. Why would I? So the sequence does not have the ability to drop. So the only rational thing I can do is to pass this guy in. So this is what it means. It means that I have to do this. So I've consumed this right now, passed it in here, it has to be consuming, then get this out back and this shit. Anyway, so no problem. Let's say invalid call of slit argument, invalid argument for self. Okay, so this means that everything works fine. It's simple. It's supposed to be this. So regardless, we don't need deduction because the type is already stated. Then regardless, let's just put it there. So yeah. So some important parts work right now. We'll test it. I'll write some test over it. I think so in the coming video, I don't know, I think I just have to do some tests to show how this works. Write complete clean text and show it works, but then let's take this to implement all the features here. So yeah, one can deposit funds and pool is created, then there needs to be a payout. You can take funds and needs to be a system that cater for interest. Okay, so I don't want to consume all everything at once, so just stay along how I dissect going about all these things revisit this as we go on, and we'll finish it and call it what it is. Right? Cheers. See you in the next video. Please stick around so we'll finish this banking infrastructure on SWI. Yeah, being in traditional banking infrastructure. Yeah, this is basic way and best way you can actually learn stuff. Just by doing